Analytics for the busy Ruby developer, Lance. 我们这一个 section 是在讲一个非常忙碌的 Ruby 开发者的故事，是请 Lance 来为我们做一个演说。
Hello, everyone. So, I'll start here with some introductions here. So I'm Lance Gleason. As you could probably tell from my accent, I'm from the United States, and this trip has definitely been a few firsts with it. Had a chance to do a little bit of scuba diving down on Green Island and a little RubyConf Taiwan thing there. And I've got a small company, it's called Polyglot Programming. And what we do basically is we do primarily Ruby development, but we also do a bit of D3.js, work with some of the JavaScript frameworks, and we also do some big data work and a little bit with wearable devices as well. Now, question here, since we just had a great talk previously on developer happiness, how many people here actually pair program on a regular basis? Do you program with somebody else? Okay, we have a few. Well, at Polyglot, we actually decided that we wanted to go a little step further than that because at times we have clients that just will not pay for a dev pair. And so we thought, what if we could take that a step further? And so we actually, we practice something called per programming. Right here, you have basically, this is my dev pair quite often, her name is Allie, and she was working on a really difficult DevOps problem here. And so, and we also have found that it really improves our developer happiness when we're having an interspecies stand-up. So you can see there, that was actually our morning stand-up. Sometimes our little guys there, though, they're not always the most motivated, but cats usually rule it, but that's kind of how that goes. You can find out more about per programming. We have a website that we set up for it, for best practices, perprogramming.com. Okay, so at any rate, we're obviously not here to talk about per programming, though that could be an interesting talk in itself. Analytics. So what are analytics? And as I was thinking about how to put this talk together, I kind of thought, quite often it's so easy to confuse analytics. You might think of a number of things, including data science. And to really kind of understand analytics, it's important, I think, to understand how does it fit in with data science? Well, what is data science? Well, you might think big data, right? You hear about big data all the time. You might think of an equation of some sort. It's science. It has to do with math. What part of this don't you understand? I mean, come on, it should be easy, right? But really, what data science it comes down to at the end of the day is it's basically just combining your hacking skills, your math and statistics knowledge, and really the substantive expertise is really referring to domain knowledge. And where those intersect, that in essence is really what data science is. Okay, great, so we kind of have a little bit of an understanding of what that is, but what are the steps that a data scientist would follow with a set of data that they might be using? Well, the first thing they might do is they're gonna gather some data in some sort of a fashion. You're gonna need to have something to work with. Well, you might use a database for that. You could use Mongo, you could use Postgres, use Redis. There are other mechanisms you can too. When we were actually working on one project, we came up with a kind of an interesting way to gather data where we had an application it needed to support a lot of users, and we thought, why not collect data that we later on want to analyze via logging? You might think at first, logging, really? Yeah, logging. And then use Amazon S3 to store it. You don't have to have these expensive data stores. You don't have to have this database that you have to maintain with right contentions and all that. You just throw it into Amazon S3. And the other nice thing about that is there's always this contention within the data science community, and I don't think there's a firm, you should do it this way or you shouldn't do it this way, as far as do you gather everything and then figure out later on how you want to use it, or do you selectively only gather data that you know you're going to want to use in the future. Except, how do you know what you're going to want to use in the future? This helps with that. Then, what we did on this is we basically just stored stuff. Now, with this being said, we still had to kind of have an idea of what we wanted to store, but we put that data in a JSON format in our log files. Then we used Amazon Elastic MassProduce and Hive later on to parse it. When I first heard about this, I was like, boy, this sounds like it's going to be kind of difficult. It actually isn't. And then finally, we ended up using DynamoDB as an easy way to get that Hive data and to then visualize it and do analysis on that data. So how do you do that? Well, basically, you use the commands. They look a lot like SQL. And I'm not going to go through all this, but I'm just kind of trying to show you in a representational fashion what it takes, which is not really that bad. So right here, we're basically saying we're going to create an external Hive table right here. We're telling it to read from our S3 bucket here. This is just boilerplate, but I've just thrown it in. We're then going to create our DynamoDB table. We're going to map everything out. Again, just an alter table thing. And then a command, again, that looks a lot like SQL to read our JSON data, populate it into Dynamo, and from there we just have a Dynamo database that we can work from. Are there alternatives to this? Yes, you could, instead of using Elastic MapReduce, you could use something like Hadoop. You could use Cassandra or MongoDB or something else like that to basically persist your data from a database perspective. We chose Dynamo because when you're on the Amazon stack, it's dead simple to use it. After you've read in your data, though, then you're going to need to clean it. And this is one of these terms that quite often when I first heard it, it's like, well, this sounds really complicated. But in essence, all that cleaning data is it's just getting it ready to do something else with. It could be as simple as having one table with customers and another table with addresses and just doing a join on that before you do analysis. It could be that it could be segmenting the data. You may have, in segmentation, when we refer to that, all we're basically saying is, for example, you may have information about customers, and you might have some demographic information about them, such as certain customers, their age is between 25 and 30. And we might be wanting to do analysis or look at visualization on just the people that are from 25 to 30, or maybe they're teenagers, 15 to 18 or something like that. We might also be working with sparse data and basically trying to clean that up. Or we may have data where we basically have some noise in there, where everything else looks to be of a certain value, and then you have something that's just way out. After we've done that, so after we've gathered our data, after we've cleaned our data, then we're going to want to do analysis. This is the interesting thing with it. We work on, occasionally our company works on problems that are in the data science arena, as we call that. But yet, a lot of customers think they're going to need heavy analysis and really don't need it. With that being said, when we do need to do analysis on that data, there are a couple of Ruby tools available that you can use. You've got the Ruby Statistics gem, and you also have the Stats gem, or Stats Sample gem. I'll be honest that we probably haven't used them a lot, but they are kind of a helpful way to basically, if you want to stay in Ruby and still be doing your analytics with it. So after you've done all that, then you're going to get into visualization. Now, with this being said, the visualization step might not be the last step when you're doing analysis. You might be using visualization to help you figure out how to clean your data. You might be using the visualization to assist you in doing the analysis or even choosing the appropriate mechanism for analysis. Are you going to do some sort of a linear regression on your data? Are you going to do a Poisson distribution? You might not have an idea until you've actually visualized that data. And another key thing, when you're working with data, if you're going to do statistical analysis on it, you're going to need a lot of data points. And not only just are you going to need a lot of data points, you're going to need a lot of data points that are related to one another. I'm saying thousands here in this slide, but really it's more in the magnitude of probably at least 10,000. 10,000 data points that are actually related to one another. If you don't have that, it's not even worth trying to do any statistical analysis on it because it's not going to be, you're not going to find any correlations that are actually meaningful. Okay. The other thing I always warn people about is when you're working with data sets, when you're doing this analysis, you need to be mindful of not coming across false positives or not basically making sure that the conclusion you come to is actually a valid conclusion and you're not just blindly following the data. And let me give you an example of this. So there's a data set that was collected recently on people who eat rice and the mortality rates and mortality information about people that ate rice. Some of the conclusions that we came to. Nearly all sick people have eaten rice. So the effects must be cumulative, right? An estimated 99.9% of all people who have died from cancer or heart attacks have also eaten rice. And another 99.9% of people who were involved in auto accidents ate rice within 60 days before the accident. And this one was amazing, right? Among all people who were born in 1839 that later died on rice, none of them are still living. Rice will kill you. Okay, so a little bit more of a realistic example. So let's say that we have an application that we're collecting data on, and we just found out that it's brand new and we just had 4,000 app downloads this month. We're doing great. Time to celebrate. We missed one key point though. Most people basically use the app once and then uninstalled it. Yeah, not very good, right? Our shopping app just saw a spike in weekly usage after I made some UI changes to it. That UI change had to have led to more users. Yep, got it. Unfortunately, that change also went live in a US market during the last week of November. And if anybody knows what happens during the last week of November in the US, that's basically the peak shopping season. Not so good. My point here is basically be wary of what we call an N of 1 experiment. And an N of 1 experiment is simply, it's saying that I have one data point and with that one data point I'm going to make this broad sweeping conclusion because it probably won't be correct. The results, more than anything else, they need to pass the smell test. So for anybody here that is kind of interested, that finds statistics and working with data sets interesting, has anybody here ever heard of Kaggle before? Wow, nobody. So this is a really cool thing. I'm giving this link right here for basically the Titanic set, and they have a number of different ones. And what you can do with this is with Kaggle, you can go on there and they have these rolling competitions. And with the Titanic data set, they give you an anonymized set of data about all the passengers that were on the Titanic. Everything from their age, the class that they booked their ticket on. They give you a certain background about where the passengers were from. And from that, you basically use statistics to predict who died and who lived. And what's interesting is you'd be amazed at just how much the numbers can tell you with that. So it's really fun to check out if you haven't done it before. Okay. So now that we've kind of had a chance to look at things from the 3,000 meter view, let's look at analytics on its own now. So what are analytics? What is analytics? And though some people sometimes will confuse it with data science that we just talked about, what it really is it's taking a mound of data and coming up with a way to visualize it in some sort of a meaningful way. It's basically visualization. For example, we might have a sparse data set, and we're looking at the data, and we might say, we might not be sure how sparse is it, are there certain clusters or different things like that with it, but by plotting that out, we can actually then definitively determine, well, yes, like if you look at this right here, these are definitely sparse data points. None of these are clustering, they're not doing anything with that. I mean, or you might even want to say, is there a way to kind of make it look like it's coming together a little bit more too? I wouldn't recommend that, but you're using it to basically help get insights into your data. It helps you to determine, are there trends? You might look at the data set. Actually, probably with this one, you could kind of tell by looking at it, but by visualizing it, you can see, oh yeah, there's definitely a trend and so on with that. So what are the tools that are available to us as a Ruby developer to visualize and to do these analytics? Well, there are a lot that are out there. And the ones that I'm going to concentrate on today are SVG-based. How many people here have ever worked with something that's SVG-based or know what SVG is? Okay, so a few. SVG is basically, it's a newer technology that's browser-based. It stands for Scalable Vector Graphics. And it's kind of become one of the de factos. Especially, it's rather one of the de facto technologies that's used quite often within, I'm going to say, the analytics community. So if you want to be able to visualize your data, you can use SVG and this gem, RubyViz, and not have to write a single line of JavaScript. So this is just a simple example of where basically you're just writing a little bit of Ruby code here. RubyViz is generating some SVG, kind of looks like this here. Gives you that graph like so. You haven't had to, no need to get into heavy JavaScript, no need to do any AJAX calls going back and forth. Simple. And if all that you need are static visualizations, this is a really powerful tool, and it's actually a great tool, or it can be just a great tool if you're just getting started. Let's say that we want to go a little bit beyond that, where we want to have some interactive graphs here. Now, how many people have ever seen some of the sort of interactive graphs that are out there when they're analytics-based graphs? Not really many, okay. One of our go-to tools that we use quite a bit is NVD3. I'm going to show you really quick here what that's about. So basically, I'm literally just coming off the website here with it. This is all created with NVD3. So a little bit of code here, and the size, let me just bring this down a little bit so you can kind of view this. Actually, that was not right. There we go. So writing just a little bit of code here, not a whole heck of a lot. I'm not going to trace through all this because we are not going to have enough time to do that. But if anybody wants to see me afterwards, we can do a deeper dive into this. But literally, what do we have here? Maybe 20 lines of code, give or take. Paint it in your data and so on, and then you have something that looks like this, where you have interactive graphs. We also have XCharts and C3.js. They're based off the same technology, so how many people here have ever heard of D3.js? Okay, there we go. Now we have a few more. All these libraries that I just showed you, they're based on D3.js, but they're just making your life easier. But as you can imagine, when we're using a library that's based on D3, but it's not actually D3, we're going to have limitations. And that's where we get into D3.js. And so I think most people here have probably seen it. I'll do a quick overview of kind of what you get with D3. So you're going to write a little bit more code with it, but the power you get is just amazing. This is right here, just a sampling of all the visualizations you get when using D3.js. Long story short, there's a lot you can do with it. This is one of my favorites, by the way, too. So here's a force-directed graph. This is completely, probably useless as far as actually doing a visualization, and I apologize, this really doesn't seem to fit on the page. Oh, there we go. Bring that back in. But I'm not sure what that would be really useful for, but it's kind of cool, isn't it? But think about that. It's the point with this is to make data fun. So here's another one that's a little bit more serious, where it's showing airport information. And the key takeaway with this is it's interactive. It's not just a static graph that you're showing. I was like, oh, okay, we have a few data points we have up here, but this happens to be showing basically different flight routes, and when you click, you hover over one, it changes to give you information about it. So right there's that flight, or the flight data that's going back and forth between these and all that. Again, powerful, kind of cool. So the idea here is with this, we're creating data-driven documents. Okay, so one thing that comes up when we're talking about this is, I've just shown you a bunch of SVG tools, and SVG is pretty much what we use. What about Canvas? Well, if we were having this discussion about maybe a year ago, something like that, the first thing you might worry about is compatibility with browsers that people are using. These days, probably not as much of a worry. We're all HTML5 compatible. It's actually supported by all modern browsers. And if you look at the graph, actually, and this is actually an old chart, but to give you an idea, so other than IE8 is not supported, but most people today, now that XP pretty much has gone by pretty much most people are going to be on IE9 or greater. You're going to have enough support to be able to use something that's SVG based. It's supported by all the versions of Internet Explorer and everything like that. Okay, so let's say you're stoked about analytics, you want to do more with it. Where can you take it from here? You could get into R. How many people here have heard of R? Ah, good. We do have some statistics people. Excellent. That's one, we've used that on a couple of projects, and I highly recommend it if you want to get a little bit deeper. The Ruby libraries are not bad, but usually when you start getting into deeper things, or if you're working with other people that are actually doing some sort of, that are specializing with stats, a lot of people don't know Ruby, and so actually it's a nice bridge language. Weka is another great one. How many people here have ever worked with Weka, or even know what it is? Wow, a few. So for those that haven't, Weka is a machine learning framework, in essence. It's Java-based, but there's nothing to stop you from using something like JRuby to interact with it. So kind of wrapping up, if there's anything you take away from this, and granted it is a short talk, it's this: use Ruby Viz for pure Ruby visualization. NVD3 or one of these other ones for the easy stuff. D3JS for loads of flexibility. Limit the data set that you use when you paint the data with an SVG framework. So in other words, when you're using D3JS, when you're using NVD3 or any of these other frameworks, you don't want to try to paint 10,000 data points on a graph. You're not going to have enough screen real estate anyways. Keep it smaller. You'll thank me for it. Don't overwhelm the user with too much information. There are a lot of visualizations that you will see out there that will have a lot of information on there, and they will be really busy. Keep it simple. We're visualizing data to make it easier to digest for people. Be wary of an N-of-1 experiment, and that's it. So, do we have any questions? Yes.
We have a microphone.
Most of the browsers already support it. But there is a problem at the point that you need to transform SVG. Because I think no major browsers allow the CSS transform of this. So there is limit of SVG usage in browsers. Don't you have this problem? Didn't you have it?
We haven't had that. I guess what problem are you referring to with that?
Like that browsers don't support SVG transform in CSS. Like when you want to, so you've got these transform functions, and I think Chrome Canary supports it, but no other browser, like the stable version.
That sounds like we have to take that question offline, I think, because I would be interested to see, I'm not sure exactly what you're referring to with that, because I mean, you take like D3JS or something like that. I've run that in, for Chrome for sure, I mean, obviously it's going to work in, but I've also run D3JS graphs in IE, Firefox, Safari.
Okay, cool, let's talk that after.
Yeah.
Is there any questions? 还有人有问题吗? Okay, let's take a 5 minutes break, and the next session will be starting in 5 minutes.